Hello fellow engineers. Welcome to our annual update on what's new in Simcenter for mechanical simulation. In the past, I focused more specifically on what's new in Simcenter 3D. But the first thing that's new this year is that all Simcenter Mechanical lines of products are now aligned to the same release cycle. Simcenter Mechanical is more than just Simcenter 3D. Instead, Simcenter Mechanical contains all Siemens simulation software that can be used within the mechanical simulation domain. So now let me introduce you to each of the Simcenter Mechanical tools. The first is Simcenter 3D, the most comprehensive, fully integrated CAE solution available today. Simcenter 3D integrates simulation workflows for a whole suite of different physics domains through a single, integrated environment. But many of you know this already from watching our previous videos. A few of the solvers that power the simulations within Simcenter 3D are also available as standalone tools for use on HPC clusters or with other pre-post systems. The first of these is Simcenter Nastran, which is a premier finite element solver for simulating structures, vibrations, NVH, and acoustics. With over 50 years of use in the engineering world, Simcenter Nastran is renowned for its computational performance, accuracy, reliability, and scalability. Another structures-based solver is Simcenter Multimech, which is a multi-scale material modeling and simulation tool that can help you predict how, when, and why advanced materials fail at the microstructural level. Materials often have very small imperfections, things like inclusions or voids, which you can model and simulate in Simcenter Multimech. This, combined with a structural solver, helps you predict product performance at a macro level. Simcenter Multimech ultimately helps you more accurately predict how products made with advanced materials will perform. Next is Simcenter Tire, which is a unique end-to-end solution for modeling tires that you can apply to applications ranging from vehicle handling to durability. Simcenter Tire helps you to effectively and precisely model highly nonlinear tire behavior, which can then also be integrated with vehicle dynamic simulation models using Simcenter 3D or other third-party simulation tools. Simcenter Mechanical isn't just for structural solutions either. Simcenter Madymo is a market leader in occupant safety simulation. Simcenter Madymo integrates multi-body, finite element, and CFD technologies in one single solver. The software includes an extensive validated crash dummy model and human body model database. All of this combined can help you perform early analysis and optimization for occupant and pedestrian safety to ultimately reduce vehicle development time and cost. Simcenter Mechanical also includes software tools used for low-frequency electromagnetic simulation. The first is Simcenter Magnet, which is a solver for simulating low-frequency electromagnetic fields, which can help you better predict the performance of motors, generators, or any component with permanent magnets or coils. Simcenter Magnet powers Simcenter 3D's electromagnetic solution, but it's also available as a standalone solver. Simcenter Mechanical also includes specialized tools that help you with designing and simulating electric machines. The Simcenter Mechanical e-machine design tools enable fast setup and simulation workflows, with hundreds of templates for the most common machine types, and each fully parameterized. You can have results in just a few seconds thanks to a combination of analytic and 2D finite element analysis. In addition to built-in design space exploration, it makes a perfect tool to size an electric machine. But you aren't just limited to the templates in the software, and you can import your own geometries for FE-based analysis for extra flexibility. The e-machine design tools have strong connectivity to Simcenter Magnet, Simcenter 3D Acoustics, and additional thermal analysis tools. Starting with the 2212 release cycle, all Simcenter Mechanical products are following the same twice per year release cadence. This makes it easier for you to remember when new functionality will be available for each product in the Simcenter Mechanical suite. Improvements in this release will help you more accurately model the complexity of your products, simulate faster, explore more design possibilities, and keep you better integrated with overall development. Instead of focusing on what's new in each Simcenter Mechanical product individually, I'll break the highlights down by industry so you can more easily see how new capabilities in these products can help you better with your specific applications. A lot is changing in the automotive sector, and as a result, so are the demands that engineers are making on their simulation tools. Electrification of automotive powertrains has profound effects on the behavior of vehicles, from electromagnetics to dynamics and acoustics performance. Simcenter Mechanical solutions include new features that help you streamline the e-powertrain simulation workflow. Additional enhancements will also improve the simulation of other automotive applications, from NVH to tires and to even windshield wiper performance. Most automakers today are making a big push towards developing and introducing many new electric vehicles. This is a relatively new application domain for everyone in this industry, and so development processes for EV powertrains are not streamlined operations. Engineers can find themselves working in specific silos from motor design, transmission simulation, and structural performance and acoustics, among others. Most likely, each of the teams in these silos are using different tools, and information doesn't flow smoothly from one silo to the next. Simcenter Mechanical can help you break these silos and stay integrated. Simcenter Mechanical can help you at every step of the way, beginning with the electrical motor design. Template-based electric motor design and simulation helps you completely automate the design, iteration, and selection process. This lets you evaluate hundreds to thousands of design options rapidly. Once you've determined a good motor design, you can then move into Simcenter 3D for more detailed analysis to minimize losses or optimize the performance when designing the end windings or connecting to the power electronic systems. These analyses can be done in 2D or 3D. Also, because we know that electromagnetic material properties are key for accurate and reliable simulation, Simcenter 3D's electromagnetic tools provide you with a comprehensive material library that allow you to take into account realistic phenomena such as nonlinearities, hysteresis, or eddy current losses. The integrated Simcenter 3D environment also helps you perform multi-physics analysis, such as coupled thermal analysis, to understand how thermal phenomena affect e-motor performance. Electrical motors move and are usually connected to a small geared transmission. So you can now seamlessly transition to analyze multi-body simulation performance of your motor and transmission within the Simcenter 3D environment. Simcenter 3D can help you automate creation of the multi-body models, including gear geometry. The multi-body simulations can give you information about loads, and you can even model gears as flexible bodies, which can then lead to more in-depth gear wind analysis, which becomes even more critical in quiet EVs. The multi-body simulation also gives you input to determine vibration of the gear house structure. This lets you perform vibro-acoustic analysis for the entire gearbox within Simcenter 3D to ensure a quiet driving experience for your customers. Since all of these analyses occur within the same environment, it's easy to pass information from one analysis type to the next. With Simcenter Mechanical, you can easily go from e-motor design through to detailed acoustic analysis and to even pre-test planning and test analysis correlation for an electric powertrain. This keeps you in an integrated workflow and reduces the frustration of having to work with many different tools with different user interfaces and data formats. With the electrification of transportation, noise is becoming increasingly important to manufacturers and end customers alike, because electric motors are quiet and don't mask the noises that combustion engines did. This means you need to consider more noise sources than you might have had to consider before. One such example is internal aero-acoustically induced noises that come from HVAC vents inside the car. Currently, engineers simulate the vent in a free field environment, as if the vent were in an anechoic room. But the issue here is that in real life, vents operate in a vehicle's cabin containing sound-absorbing properties, such as a padded roof or porous seats. These will affect the sound the passengers will actually hear. Simcenter 3D acoustics can account for how the sound waves reflect off interior components in an actual cabin. And in this release, you can now simulate models with heterogeneous fluid domains. This means you can model the seats, for example, as heavy air or as a real porous material, even while the rest of the cabin is modeled with regular air fluid elements. This results in a more accurate representation of the sound experience in a car cabin. Another interesting engineering challenge in the auto industry is the performance of windshield wipers. A good performing wiper blade needs to have a consistent load as much as possible as it moves across the curved surface of a windshield. But the load can't be too light, nor can it be too strong. Inconsistency in the loading will leave streaks that the driver needs to peer through. Today, engineers look at wiper loading through either physical testing with some specially designed sensors, or some engineers have access to a combination of in-house and commercial software tools that just create basic 2D plots. But Simcenter 3D introduces a better way. The new contact pattern display in Simcenter 3D Motion can help you visualize wiper contact patterns. By modeling the wiper as a flexible body combined with contact elements in Simcenter 3D Motion, the new contact pattern display will show results in a very easy to interpret plot and animation of the wiper forces across the windshield. This lets you easily see how consistently or inconsistently the forces are distributed and if your wiper design will work as expected. This new capability isn't just applicable to wipers, and it can be used in other applications that use more than one contact element. Driving simulators and hardware-in-the-loop setups require high-fidelity tire models. However, a large amount of road data needs to be exchanged between the road and tire model at every simulation time step to reach high fidelity. Not surprisingly, this is a major contributor to computational effort and can be a hindrance to real-time use of tire models in simulators or hardware-in-the-loop systems. In some cases, you might reduce tire model complexity to get around this issue, but then you're also not accurately replicating behavior. In this latest release of Simcenter Tire, we've updated the road contact algorithm to reduce road data exchange. What this means to you is an increased computational efficiency of 45%, so that high-fidelity tire models can be used in real-time applications. The Assembly Composer in Simcenter 3D has been a huge help to engineers who want to model and manage full vehicle FE assemblies more easily. The Assembly Composer gives you a 2D system view of the assembly that helps you quickly visualize and understand how assembly components are connected together. This 2D system view is then directly synced to the 3D FE model. What's new in this release is the ability to extend the Assembly Composer to utilize reduced order models as components, such as FRF data that could come from physical testing in Simcenter Test Lab. Hybrid models that combine FE components and FRF or other reduced order models let you quickly explore more possibilities by simulating more model variants faster. Airframe and rocket engineers rely heavily on simulation, and the simulation tools in Simcenter Mechanical are a valuable part of an engineer's toolbox. New capabilities in Simcenter 3D and Simcenter Nastran can help you calculate the margin of safety faster, model the complexity of thin aircraft skins better, and help you understand how liquid sloshing in fuel tanks can impact launch dynamics. Structural assessment is a mandatory requirement for certification of an aircraft, but the simulation process to get the results needed can be a real headache. Engineering departments spend huge amounts of effort on developing scripts to automate the assessment for a given set of modeling rules for the Global Finite Element Model, or GFEM for short. But GFEM models change. In turn, scripts need to be updated accordingly, and the team will also need to validate the work. Finally, the team may need to add changes, such as additional dimensions to the UI. So what at first seemed like a small task escalates into an extensive project that's really secondary to the team's job, which is structural assessment of the aircraft. Simcenter 3D offers an out-of-the-box solution for margin of safety analysis that takes you from CAD to load identification and ultimately to stress reporting through a fully integrated environment. Over the past year, we've introduced new standard calculation templates that can help you automatically pre-fill all the inputs based on a set of modeling rules. All that remains for you to do is just pick the geometry needed for the calculations. We've also made it easier for you to deploy these templates across your stress organization so that everyone has access to the latest and greatest. Now your stress engineers can really be stress engineers instead of acting like IT personnel. Another unique aspect of airframe engineering is that airframe structures have thin skins, which have different stiffness behavior for tension and in compression. In tension, the skin has membrane stiffness, and in compression, the stiffness is primarily from shear. This creates a challenge because current FE element formulations can't handle this. So airframe engineers would need to create different models with different properties to account for all of the different loading conditions. To help solve this problem, Simcenter Nastran has a new nonlinear tension-only quad element. Depending on the loading condition, the tension-only quad will automatically change from membrane behavior to shear behavior. This means you now only need one model to represent your structure for any loading condition, which reduces your simulation process time by 80%. Many rockets are powered by liquid fuel stored within tanks inside the rocket. But as you know from holding a cup in your hand, movements cause that fluid to slosh around. Rockets create a lot of vibration and movement, and the resulting movement of the liquid-filled tanks can pose a challenge to guidance systems as the liquid sloshes around. So it's critical for engineers to understand and control sloshing behavior. In this latest release of Simcenter Nastran, we've introduced new methods that can help you simulate sloshing. The incompressible fluid model in Simcenter Nastran helps you predict slosh frequencies and hydroelastic modes. And sloshing isn't just isolated to aerospace and rocket applications. You can also use this capability for evaluating sloshing in cargo, ballast, or fuel tanks of large ships, automotive vehicles, and rail cars. Linear static solutions are the most widely used solution type in many industries. But how do you know if the results you get are accurate? Engineers often use correlation methods to compare results from one analysis with another analysis that they know is accurate. However, analysis correlation to date was only available for dynamics and not linear statics. Now Simcenter 3D allows you to better understand FE model behavior by comparing static displacements with another set of static, modal, or dynamic displacements. New error metrics help you to determine the degree of similarity between different load cases and whether static and dynamic solutions can be interchanged. For example, you can run a comparison between results from a coarse mesh versus results from a fine mesh model. If the coarse mesh model correlates well with the fine mesh, then you might be able to use the coarse mesh model for future applications, which can ultimately save you time in the future. Machine customers expect their machines to last with little downtime. However, machine manufacturers don't have the time or resources to physically test their machines to the limits. Simcenter Mechanical includes new capabilities that can help you more easily predict durability without being a durability specialist. Simcenter Mechanical can also help you better understand the performance of rotating machines and assess noise from electrical transformers. As I stated, industrial manufacturing companies expect the machines deployed on their production lines and shop floors to last with little downtime. This means developers of those industrial machines need to consider the strength needed to withstand all potential loading conditions of their machines up front during development. Additionally, machines must also meet regulatory requirements that engineers need to take into account during development. But the process for predicting the strength can be tedious for engineers, requiring one set of tools for performing the initial FE analysis and then another set of tools for strength and durability analysis. Smaller companies might not even have durability specialists on hand, and physical testing will take too long and be too costly. Many of you may be familiar with the German FKM guidelines, which are considered as a de facto standard in many industrial fields to certify for safety against fatigue. Simcenter 3D streamlines and automates the strength analysis that adheres to the FKM guidelines, so that Simcenter 3D can compute the FKM parameters directly from your stress analysis results. You're then ready to run your strength analysis, and Simcenter 3D will automatically create a full report in addition to the usual results visualization and animation capabilities in Simcenter 3D. This greatly simplifies the strength analysis computation process for non-expert durability analysts, while giving you results that adhere to widely recognized guidelines so that you can ensure your machines will meet or exceed operational requirements. Power transformers must meet very strict noise emission standards, mostly focusing on the so-called hum noise. Besides from being an annoyance, this noise can give the perception of bad quality of the transformer. For some OEMs to qualify the aero-acoustics models for transformer development, the noise accuracy threshold is relatively high at plus or minus 2 dB from the measured results. Therefore, the power transformer design process needs to be fast and accurate because of the high variability of transformer models, depending on their application. Simcenter 3D can now simulate the complex, multidisciplinary magnetostriction effects that cause transformer noise. In addition, you can use these forces for noise and vibration assessment without ever leaving Simcenter 3D. This means you can accurately simulate and predict the electromagnetics and acoustics performance all within the single Simcenter 3D environment, reducing the time to ensure transformer meets noise requirements. Industrial machines often have rotating shafts spinning at high speeds, which then also vibrate. That's why engineers use rotor dynamic simulation and Campbell diagrams to understand the vibration frequencies of a system at various operating speeds. However, Campbell diagrams are for linear systems. What happens when your machine uses nonlinear bushings? You now have a nonlinear system. So how do you assess critical speeds for this system? Simcenter 3D can calculate complex modes during a nonlinear harmonic response. After the analysis, you can generate a Campbell diagram in Simcenter 3D so that you can assess critical speeds of a nonlinear system. Simulation engineers, whether you're in the auto, marine, or consumer products industries, perform many of the same kinds of simulation tasks and processes and confront many similar challenges. New capabilities in Simcenter Mechanical can help you simulate the additive manufacturing build processes faster and easier than before, as well as help you pre- and post-process FE models more efficiently. Additive manufacturing is a great new method for producing parts and products across a number of industries. However, the engineers involved with the additive manufacturing process usually aren't specialized CAE engineers, so models based on high-end FE-based meshing methods, although more accurate, can be challenging to create for non-simulation experts. In the latest release of Simcenter 3D for additive manufacturing, we're introducing a new module called Simcenter 3D Powder Bed Fusion, or PBF for short. The advantage is that it's very easy to use and you don't need to spend time creating a detailed mesh of your part. It's using a robust voxel-based mesh in the background that you can quickly model and simulate the PBF build process for your part. You can then get a good understanding if your part will build successfully before you ever make a physical print. Building an FE model from a complex CAD assembly requires many steps. One of the most challenging steps often is in the modeling of different connections between components. This is challenging because there can be hundreds or even thousands of these connections, and there's also many types of connections like rivets, bolts, spot welds, and seam welds. The CAD model usually has these connections already defined, so why can't FE pre- and post systems reuse this information? Many FE engineers have customized code and processes that they've developed just for this single task, which is inefficient. For customers using CAD data that comes from NX, Simcenter 3D will automatically create connection elements and their topology based on the rich connection definition contained in NX Join. This can save you loads of time, and you no longer need to manage any customized code or processes. Fans, propellers, and air turbulence in general generate noise that can be unpleasant to the ear. But simulating aero-acoustic phenomena is a challenge because it really requires two simulations: CFD simulation to determine the flow field, and then an acoustic simulation. Even though the CFD simulation usually takes the longest to solve, the successive aero-acoustic simulation can also take up to 12 hours depending on the application. In the latest release, Simcenter Nastran gives source elements frequency-varying element orders. The end result is improved solution speeds for aero-acoustic simulations by up to 60%. Last year, we introduced the ability to efficiently launch simulations to remote HPC systems directly from within the Simcenter 3D interface. This simplified the whole launch process for engineers. And to help save you even more time, you now have the ability to preview basic results of your simulation directly from the remote simulation interface. That helps you decide if your simulation job ran correctly before you spend the time to transfer the results back to your local machine for in-depth evaluation. Additionally, remote simulation can also interface with other load balancing software like PBS or LSF, and you can also manage remote disk space from within the interface. When performing nonlinear analysis, you often need to account for parts, bodies, surfaces, and edges coming into contact with one another. For large models, managing all of these different contact definitions can become a real challenge. The new Contact Manager in Simcenter 3D can help you review all contacts in your model, including glue connections, all under one central place in the user interface. You can also compute initial contact results in the form of contact status, penetration, and gap values. This saves you time and lets you easily confirm if your contacts are defined correctly in your model to accurately capture behavior. I hope you learned how recent updates across the Simcenter Mechanical suite of simulation tools can help you model the complexity, go faster, explore possibilities, and keep your simulation processes integrated with development for all of the interesting applications you're working on today and in the future. And again, these were just the highlights, and there are many new capabilities in each of these products that could be of great help to you. To learn more, you can visit Support Center and view the online help for these products. Another valuable resource that you can access from Support Center is the Simcenter community, which includes a forum where you can discuss topics on using Simcenter 3D, Simcenter Nastran, and all of our other Simcenter Mechanical products with other customers and users of those tools. The community also includes knowledge-based articles posted by our support team and others that can provide insightful tips on using the software. Another recent addition you should bookmark is the Siemens Mechanical How-To playlist on the Siemens Software YouTube channel. There you'll find a number of short videos highlighting specific applications and procedures that can help you be more productive with Simcenter Mechanical simulation tools. You can find a direct link to the playlist in the description below. And that brings me to the end of this presentation. Thank you all for taking the time to attend, and we look forward to seeing all of your future innovations.